Welcome back to the Web3 Security series. Today we are discussing denial of service or DOS attacks, a serious vulnerability that can make smart contracts unusable. I'll explain how these attacks work, show a practical example with the bidding contract in Foundry. Let's get started. A denial of service attack in smart contracts occur when malicious actors prevent legitimate users from using the contract's functions. In blockchain, it often happens when contracts rely on external calls to send ether, depend on actions from previous participants, or loop through unbounded arrays. Today we'll focus on the first type using vulnerable auction contract. DOS is when only one person is causing the attack. If multiple people are causing the attack, we call it distributed denial of service attack, that is DDoS. Let's look at our vulnerable auction contract. It seems simple. Users can bid more Ethereum than the current highest bid, and the previous bidder gets automatically refunded. So here you can see there is a place bid function, and if a person places a higher bid, it just updates the state and refunds the previous bidder. So here the vulnerability lies in the automatic refund mechanism. When sending ether to the previous bidder, we are making an external call that could fail. So here you can see that I have a malicious bidder. In this contract, it's a very simple contract where you can observe that there is no receive or there is no fallback function. So when the auction tries to refund the malicious bidder, it is going to fail every time. Initially, what I'm going to do is I'm going to give 5 ether to each of them. Then I'm going to deploy the contract, vulnerable auction and the malicious bidder. And in the test DDoS, what we are going to do is Alice places the first bet, that is 1 ether. Then Bob places a higher bid, that is 2 ether. Then the attacker, the malicious contract, places a higher bid, that is 3 ether. And then when Carol tries to bid higher, then it fails. Let's run the test. Here, when I run the test, you can see the test case passes, and in the logs we can see that initial state was this, like highest bidder was 0 and highest bid was also 0. After Alice's bid, like Alice paid a bid of 1 ether, so Alice becomes the highest bidder and the highest bid becomes 1 ether. Then Bob places a bid of 2 ether and Alice is refunded her 1 ether. So Bob becomes the highest bidder and the highest bid is 2 ether. Now the attacker places a bid of 3 ether. So Bob should receive 2 ether. So attack was successful because Bob's refund was rejected. So after the attacker's bid, you can see that the attacker is the highest bidder and the highest bid is 3 ether. Now when Carol tries to bid 4 ether, as you can see that the attacker did not have a receive or a fallback function, so the refund can never happen. Because the refund can never happen, Carol cannot use that function anymore. Now the auction is permanently stuck. And the final state is that the attacker is the highest bidder and the highest bid is 3 ether. Now you would be wondering how we can prevent DOS attacks. I have written a safe auction contract here. So it's the same contract, but I have used a different strategy to write this contract. It is called a pull method. So instead of refunding the previous bidder, we are going to let the bidders withdraw their amounts. So here you can see we have the place bid function. So add previous highest bid to pending returns. So it is going to store all the ether of all the bidders and it is going to update the auction state. And we have a withdraw function that the previous bidders can call. If the amount is greater than 0, they can call and get the refund. So the key improvements are separate bid placement from refund withdrawal, store funds in a mapping, and let users withdraw their funds later. So there are no external calls during critical operations. So let's clear and try to run the test for safe bidding. You can see that initial state is 0. Alice pays a bid of 1 ether. Then Bob places a bid of 2 ether. Alice's pending refund is this much. So Alice successfully withdraws her fund and Carol places a bid of 3 ether. Bob's pending refund is 2 ether. And the final state is like Carol becomes the highest bidder with 3 ether. So by this we can prevent the DOS attacks. Don't forget to check out the code in the description and hit like and subscribe for more Web3 security content. Thanks for watching.